Welcome to analytical balances. Analytical balances are perhaps the most commonly used piece of instrumentation that you'll be using in the lab. These are our three analytical balances that you'll be primarily using. In the back of the lab, I hope I didn't make you seasick, we also have two analytical balances right there on the table. You'll see it with the one in the glass house, and then its squat, plump one with an opaque house right back there. We'll talk about them in a second. Most of your labs will be done using with these three balances. The first thing you have to know about your balance is how to turn it on. To turn it on, you hit the power button. It looks like a circle through a line like an old-fashioned computer's power button. There are a couple other important features to notice about your balance. First, notice your number of sig figs here. You can go all the way to the 10th of a milligram, or 4 decimal places on a gram. 4 decimal places on a gram. So when you use one of these balances up here, you need to write down all your measurements to that decimal place. Don't sacrifice any sig figs this instrument gives you. Write them all down. Some other piece of glassware or some other piece of instrumentation you use may limit your sig figs, but this balance should never limit your sig figs if you're writing them all down. Write them all down. Don't disregard any of them. Write them all down. Because that's the number one mistake I'll see people make in their lab. For some reason, they'll decide, I'm just going to write down 2 of the numbers the balance gives me. I'm just going to write down 3. Write down every single number this balance gives you. All right, now that I've beat that horse into the ground, first thing you'll notice about these balances is they live in a glass house. The reason is that they're very, very sensitive. See, I've opened the door of the glass house, and I'm just waving my hand here back and forth, and look at the numbers on the screen. See, those numbers on the screen are changing, and that's just me waving my hand. Air conditioners, people walking by can cause these balances to go crazy. So whenever you take a measurement, prevent the balance pan from being knocked around by making sure that glass house is completely closed. Also, whenever you take a measurement, your balance should read 0, 0. Because I was messing with the balance, generating all that air current, it's not at 0, 0 anymore. You can correct this using the 0 tare buttons. That's 0 and tare. And what that does is that resets the 0 on the balance. And see, I'm back to 0, 0. This is also useful if you're weighing chemicals. Remember, never weigh chemicals directly onto the balance pan. They either should be placed in a piece of glassware or a weigh boat. I'm a big fan of weigh boats. We also have wax paper available if you prefer, but I'm a big fan of weigh boats. I'm a little too clumsy for the wax paper there. All right, so there's my weigh boat. I've placed it on the pan. You'll notice it has mass. I can use that 0 tare button to get rid of the mass of my weigh boat. So I press 0 tare, and you can see the weigh boat's still there, but it's now reading sometimes you have to press tare more than once. It's now reading 0, 0. Okay. One other thing is, we've got these balances on lovely, beautiful marble tables. Therefore, it's very hard to knock them around. That having been said, if anybody is leaning against the table, and you can't really see it, but I'm bumping my hip into the table, and what you'll see is the measurements change as I bump against the table. These marble tables limit that effect. Those two balances on the back wall, however, they are going to go crazy anytime you jiggle that back bench. So make sure no one's leaning against that back bench if you're using one of those balances back there. One other thing is these balances should always be left clean and off when you're done with them. When you're through, your weigh boat should be off the balance and in the trash. If there's spilled chemicals, we have a paintbrush here, not to do some painting, but to use as a brush to brush and clean off your balance. Then make sure you power them off. Because these balances cost $2,000 to $3,000 each, you are responsible for their care and upkeep. If the balances are left on and in a dirty condition, students will be assigned a balance, and as a group you will take collective responsibility for that balance, and your grade will be penalized every day the balance is left in poor condition. One other thing before I forget, these balances up here, they have a weight limit of about 50 grams. Anything over 50 grams, you're going to have to use the balances in the back. The balances in the back can't measure those 4 decimal places on the gram. They can only measure 3. So you lose a little bit when you go back there, but there you can usually weigh up to around 5 kilograms. So you can weigh more, but you lose some precision. The final thing on balances is I want you to write down the word bullfrog before I tell you it. Write down the word bullfrog. I hope you're writing down the word bullfrog. Did everybody write down the word bullfrog? All right, after you've written down the word bullfrog, I want to talk to you about balance monogamy. All balances have a little error or a little bias to them. A lot of the work you'll be doing will be mass by subtractions. You'll be subtracting different masses from each other. And therefore, if you practice balance monogamy, and what that means is if you take your first measurement for a lab on this balance, if possible, take all your measurements for the rest of the lab on this balance. Sometimes it won't be. You'll have to go use the one in the back. If possible, take all your measurements on the same balance. If you start the day using this balance, take all your measurements that day on this balance. And hopefully any bias the instrument has will subtract out when you're doing those masses by differences. That's it. Beep.